Hello, my name is Kyle Worth, and this is Heat Transfer in a Double Pipe Heat Exchanger, brought to you by my team from the University of South Florida. In this video, we'll be going over the main concepts and objectives of this lab, the safety considerations to perform it without accident, the equipment that was used, and the procedures to be followed. The objectives of this lab are to provide an in-depth analysis of double pipe heat exchangers. In doing so, we calculate an experimental overall heat transfer coefficient from the data gathered, and observe the difference between this and the predicted heat transfer coefficients from literature. We're also interested in the difference between heat gained by the cold water and heat lost by the hot water. Heat exchangers come in many varieties. To sum a few, there are double pipe heat exchangers, shell and tube heat exchangers, cross-flow heat exchangers, and fin tube heat exchangers. The common property between all of them is that thermal energy is exchanged between two streams, a process stream and a utility stream. Commonly, utility streams are cooling water if the temperature bounds will allow for it. To model heat exchangers, there are two governing equations: an energy balance over each half of the heat exchanger, both the hot and the cold, and an energy balance for the system. Some safety precautions before starting the lab. Do not wear latex gloves. The heat exchanger radiates heat outward, so that means the material will be hot and the latex can melt, so please use proper insulating material. Be on the lookout for spilled water and leaks. Given that this is a flowing system, you can anticipate that water will escape from the pipes. This unit does have a basin to capture water underneath, but if maintenance should go awry, that means that a puddle could appear underneath, and that becomes a slipping hazard. Electrical components are present, so please do be cautious and aware of exposed wires, as they can be a hazard for electrical shock. Going over the materials and equipment of this lab, we used an HT31 tubular heat exchanger, as well as hot water and cold water for our process and our utility streams. An HT30X Anfield heat exchanger was used as our service unit. Before startup, make sure that the reservoir is filled with water to the fill line. You can find this reservoir right here, attached to the white box near the rear right of the unit. Once we've determined that the reservoir has been properly filled, we turn the cooling water on at its source and position the cooling water outlet over a drain. You can see that this drain is on the lab floor, so we position a chair over it to ensure that we don't create any additional hazards while we run the experiment. This is the user interface that we'll be using to monitor the flows during our experiment. First, ensure that the power is turned on. Next, change the temperature set point to 70 degrees Celsius. This can be done so by using the up and down arrow keys here. Our next two steps are going to be done in the middle section of our user interface, right here. We'll be adjusting the cold water valve to 1 liter per minute and the hot water valve to 3 liters per minute. The dial to the right, F hot and F cold, indicates the flows that are being read. Adjust each valve accordingly and ensure that the flows have reached steady state before continuing. Finally, monitor our cold temperature outlet, T6, and record the temperature versus time to show that steady state has been reached. Once steady state has been reached, record all of the temperature values as well as the flow rates of the cold and hot utilities. Then we adjust our cold valve until the cold flow rate reaches 2 liters per minute, and again log our temperature versus time until steady state is reached. Finally, log all of the temperature values again, along with our flow rates for the cold and hot utility streams. You now have enough experimental data to perform data analysis. If you have any questions, please refer to the lab manual or your lab head. Thank you for watching.